This is the opposing nature of flowing source. Opposing nature of flowing source. Kintu jeng because scientifically malirgan na. To write it in scientifically, we need what definition. So this type of question is not coming. These are not for examination target. Resistance of conductor. These are not for actually what examination purpose, but we should know all of these things properly. So write it. Resistance of a conductor is defined as, okay, resistance of a conductor is defined as the ratio of potential difference, as the ratio of potential difference applied across it and the current flowing applies across it and the current flowing through it, and resistance conductor defines the ratio of potential difference between the across it and current flowing through it, and current flowing through this is R flowing through it. That means what? Resistance is ratio of what? Potential and current flowing through it. Potential difference and current flowing through it. This is the definition. So what is the SI unit? We know it already. What is the SI unit of resistance? Okay, it is what? Ohm. There is no need. Symbolically it is written like this, omega. Resistance. Electrical resistance. So resistance of a conductor is what? Directly proportional to what? Potential difference, and inversely proportional to what? Electric current. Current ni ultha ruju theory. Ohm. So now next topic is what? Resistivity or specific resistance. We already got in class 10. What is resistivity and or specific resistance? Class 10 now. So resistivity, or sometimes it is said as what? Specific resistance. Specific resistance. And symbol is what? Symbol is rho. Okay, this is not actually P. This is what? Rho. Be a rho, sir. This is Greek alphabet. Be a Greek alphabet rho, sir. That be a going to pick resistivity or specific resistance. Resistivity specific resistance. So the resistance of a conductor is directly proportional to its length and inversely proportional to its cross-sectional area. The resistance of a conductor is directly proportional to what? Directly proportional to length. Directly proportional to length of the conductor, and inversely proportional to what? Cross-sectional area, and inversely inversely proportional to cross sectional area. Cross sectional area. Understood? What is the meaning of this? Directly proportional means what? Resistance is directly proportional to length of the conductor. माने दैदेनग्रानि लावथायनि strength रुजुथायारि ना. And inversely proportional to what? Cross sectional area. Suppose cross sectional area is this one. What is the meaning of cross section? So this is, suppose this is a conductor, and if you cut it small piece, then you will get what? Like this. Perpendicularly, if you cut it perpendicularly, then you will get what? Small circle. And area of this circle is what? Cross sectional area. Okay, this is not obliquely. Okay, this is what? Straight, perpendicularly. So it is what? A. It is indicated in bed. So if you combine it, you will get what? After combining it, you will get you combine it, you will get what? Or in physics, we are not using implied symbol. We are generally what? Using or na eba. जोङो फिजिक्सआव generally implies maths आवसो implies use खालामो. Instead of implies, we are using what? Or in physics. So or R is directly is proportional to L into 1 what? L. Is A. So after combining, you will get it. Okay. For this proportional, let us bring proportionality constant. Okay. R equal to rho L by A. This is the term. Okay. This is the term rho, which is proportionality constant, and this is known as what? Specific resistance or resistivity. Where rho is what? Constant of proportionality. Constant of proportionality known as specific resistance or resistivity ना. देखो माने specific resistance or resistivity ना. I'm sorry. Suppose if length of the conductor is what? 1 meter, and cross sectional area is suppose 1 meter square, then R equal to what? Rho L by, that means L means what? 1 meter by, sorry, this is meter square. Okay, 1 meter by what? 1 meter square. You will get what? R equal to rho, and this will be what? R meter. Okay, so remove this, just calculate this only. Okay, so what is the unit of resistance? Ohm. And what is remaining there? Meter only. So this will be ohm meter. Okay, so R equal to rho. Okay, so SI unit will be what? SI unit is what? Ohm meter. Okay, so SI unit is ohm meter. So next topic is what? Next topic मा जागोन जोंना conductance ना. Conductance सिगाङाव जों capacitance discuss खालामबाय ना. दाना conductance आलाय मा? This is the ability to conduct ना. Capacity ability to conduct electricity or charge to it. This is what? Actually mathematically this is inverse of resistance. This is the opposition of what? Resistance. Resistance ni ulta हेंथा. जेनेबा हमना ला मोब्लिब बोहैनायनि माबाया मालाय resistance. What is the resistance? It is the opposing nature of what? Flow of charge ना. Charge बोहैनायनि ulta na ulta kintu mamlai dana now what is the capacitance actually conductance is what inverse of what opposition of what opposite nature of what resistance so what will be this what can be ease of doing ease of flowing what ease of flowing charge na mane सहजै चार्जआ माबायदि बोहैलांनो हायो बेखौनो मानगोन ease of flowing charge is what conductance so mathematically what capacity conductance माने उले बे हिसां गोरलैयै मोब्लिब चार्जआ मोनसे दैदेनग्राजों कन्डाक्टरजों बोहैनो हागोन हा with how much easiness it can charge can flow through a conductor so it is known as what ease of flowing charge so in mathematically what the inverse of resistance is the inverse of resistance is conductance is called conductance it is what that is conductance it is represented with what capital C but don't get confused okay sometimes capacitance also written with capital C capacitance conductance also written with capital C 1 by R okay it is the reciprocal SI unit will be what SI unit will be this is ohm okay inverse ohm will be what sometimes it is represented what inverse ohm or mho MHO ohm is what ohm is OHM okay mho is what MHO so it is written how MHO opposite of or sometime or Siemens okay now next time conductivity this is represented with what small sigma okay जों बेखौ माखौ जों दिन्थियो स्मॉल लेटर सिग्मा जों हा सिगाङाव जों मामोनलाय conductance is reciprocal of inverse of what resistance now conductivity is reciprocal of what inverse of ulta माने उल्टा जागोन बे resistivity this is the reciprocal of what resistivity conductivity is reciprocal of resistivity ना reciprocal माने उल्टा 1 by the inverse of similarly right the inverse of resistivity conductivity resistivity or specific resistance okay resistivity is called or known as conductivity it is what conductivity is sigma equal to 1 by rho then what will be the unit SI unit so rho is what ohm meter and then per ohm per meter okay or mho meter mho per meter okay or Siemens per meter okay बुझबाय ना जाबाय now next one is what is ohmic conductor ohmic conductor Even though writing it's okay. Ohmic conductors are those conductors which does not follow the Ohm's law. Okay, they are not obeying the Ohm's law. बिसोरो Ohmनि खान्थिखौ मानिया. जायफोर कन्डाक्टरफ्रा दैदेनग्राफ्रा Ohmनि खान्थिखौ मानिया बेखौनो मा होनोमोनलाय? Non-ohmic. Which do not follow the laws of Ohm's law, then this is not non-ohmic. Which are following, these are ohmic resistance, which are not following, they are what? Non-ohmic resistance. जायफ्रा Ohmनि खान्थिखौ मानिगोन बिसोर मा? Ohmic resistance आरो जायफ्रा Ohmनि खान्थिखौ मानिया बिसोर non-ohmic resistance ना जाबाय बेखौ लिरलायाबाबो जागोन ना ओमफ्राय दाना superconductivity superconductivity means what? The resistance of most metals decreases with fall of temperature. If temperature is decreasing, then resistance is what? Decreasing. If temperature is increasing, then resistance is what? Increasing. जेब्ला temperature खमायो, resistance खमायगोन. जेब्ला temperature बारायो, अब्ला resistance बारायो. Like this. So and a process to zero at about zero. Now, in some cases, okay, in some substances, resistance of this kind of objects decreases up to zero. It becomes zero. That means what? There is no resistance. Resistanceless. In some cases, what? If temperature falls down such like point, that resistance becomes zero. Then this type of material is known as what? Superconductors. And this situation is known as what? Superconductivity. This state is known as what? Superconductivity. जाय समावहाय मा गुसुआ जालाङोब्ला ना टेम्पारेचारा खमायलाङोब्ला मोनसे समाव मा जाहैगोन होनब्लाय रेजिस्टेन्सआनो जिरो जाहैगोन completely conductor. Resistance is zero. That means what? This is totally that means full conductor. It can conduct fully. No resistance is there. That means what? And that kind of thing is what? Superconductor. Actually, in reality, such kind of things are not exist. Okay. This type of things are not exist really, but almost zeros are there. जोंहा बेयाव zero जाहैनाय जिनिस मोनथावा किन्तु मा theoretically, but it is theoretically accepted. Okay. Now, right? Superconductivity. The resistance of most metals decreases with fall of temperature. Fall of temperature and a process to zero. And a process to zero. At about this phenomenon is called phenomenon is called बे नुथायखौनो मा होनो बे थाथायखौनो called superconductivity. And the material is known as called and the substance is called, and the substance बेसादखौ मा बुंनाय जायो, and the substance is called, बेबायदि बेसादखौ जों मा बुंगोन, superconductor. So applications where it is applied actually. Superconductors are generally used in what? Electronics, suppose computer. Okay, inside there some chipsets. That means logic gates also there. In your second year, there is a chapter digital. Okay, I forgot the name of chapter. Digital electronic devices like this. Electronic device ni sayaw. And there is logic gate. Logic gates are also there. So because unni chapter 4 discuss खालामोन ना, chapter 10 नामायाव दंमोन. And electronic communication also there. Applications where it is applied. Superconductivity is used to produce superfast computers. Okay. Used in where? Superfast computer. Superfast computer. Computers. Second, superconductors are used for transmission of electric power. Used in transmission of electric power without any loss of energy of electric power. Electric power without any loss of energy. So because there is no resistance, no loss of energy. Okay. Now, depending on conductivity, materials are divided into three parts. Mainly, there are three types. What are they actually? Conductors, you know it. What is conductor? And insulators. What is insulator? Do you know? Insulator means what? These are not conducting electricity. Okay. And semiconductors. What is the semiconductor? Semiconductor is like the substance which are between what? Conductors and insulators. They are both what? Conductor and insulator also. But they are not good conductor, not good insulator. So you are not writing about this.